Have you ever wondered how devices on a network communicate with each other? It's a question that may not keep you awake at night, but it's one of the cornerstones of our digitally connected world. You see, every device on a network, from your smartphone to the server hosting your favorite website, needs to talk to each other. This communication is the lifeblood of a network, and it's where our story begins. But it's not just about sending messages back and forth. Oh no. It's about doing so in the most efficient, effective way possible. Because when it comes down to it, the overall functionality of the network is at stake. If devices can't communicate effectively, then the network can't perform its tasks efficiently. So, how do we ensure smooth, seamless communication between devices on a network? That's where the magic of subnet masks and subnetting comes into play. Intrigued? You should be. Now, let's delve into the fascinating world of subnet masks and subnetting. To comprehend the concept of subnetting, we must first understand what a subnet mask is. A subnet mask, as the name suggests, masks or hides the identity of an IP address. It's like a cloak of invisibility for the IP address, providing it with a certain degree of anonymity. But why do we need to hide an IP address? Well, it's not so much about hiding as it is about distinguishing. You see, an IP address comprises two parts, the network portion and the host portion. The subnet mask's job is to differentiate between these two parts. Now, let's delve into the structure of subnet masks. Much like an IP address, a subnet mask comprises 32 bits. These bits are divided into 4 octets, each containing 8 bits. The bits in a subnet mask can be either ones or zeros. The ones typically come first, representing the network portion of the IP address, and the zeros follow, representing the host portion. But how do we denote these subnet masks? Well, we use binary and decimal notations. In binary notation, a subnet mask will look like a string of ones followed by zeros. For instance, a subnet mask for a Class C IP address in binary would be 11,111,111.1111111. 11,111,111.000000000. However, binary can be a bit cumbersome, so we also use decimal notation. This transforms the binary string into 4 numbers separated by periods. Using our Class C example, the binary subnet mask becomes 255.255.255.0 in decimal notation. Remember, the purpose of a subnet mask is to help the system determine the network and host portions of an IP address. It's a fundamental aspect of network communication and plays a vital role in the process of subnetting. With that, we have a basic understanding of subnet masks. Let's move on to the next step, subnetting. Subnetting is like slicing a cake into smaller pieces. Let's learn how it works. Imagine a large network as a cake. If you try to serve the whole thing at once, you're going to encounter some issues. It's unwieldy, hard to manage, and not conducive to efficient distribution. But what if we could cut it up into more manageable pieces? That's precisely what subnetting allows us to do in the realm of network communication. Subnetting is a practice of dividing a network into 2 or more smaller network segments called subnets. It's like carving out smaller, more manageable pieces from a larger network, much like how you'd slice a cake into individual servings. The slices or subnets are still part of the larger network or cake, but can be managed separately. Why do we do this? Well, subnetting brings a host of benefits. One of the key advantages is improved network performance. By breaking a larger network into smaller subnets, we reduce network traffic, lessen the load on devices, and increase overall network speed. It's like having fewer people sharing the same cake slice. Each person gets a bigger piece faster. Another significant benefit of subnetting is enhanced security. By segregating a network into separate subnets, we create additional barriers to potential intruders. If one subnet is compromised, the others remain secure. It's like if someone drops a piece of cake, the rest of the cake is still safe to eat. Let's walk through a simple subnetting example to illustrate the process. Suppose we have a Class C network with an IP address range of 192.168.1.0 to 192.168.1255. If we want to create 4 subnets, we would divide the total range into 4 equal parts. Each subnet would then have its own range of IP addresses, providing a more manageable, efficient, and secure way to manage network communication. In essence, subnetting is an art of network management. It requires a good understanding of IP addressing and careful planning, but the rewards are worth the effort. It's not just about slicing the network cake into smaller pieces, but about serving them efficiently and securely. Subnetting, as we see, has a significant impact on the efficiency of network communication. Now, let's introduce a handy tool in network configuration, the IP Subnet Calculator. This tool is a lifesaver for anyone treading the complex paths of network configuration. It's akin to having a reliable compass in the intricate world of subnetting, guiding you through every step and decision. You see, the IP Subnet Calculator simplifies the subnetting process by automating the calculation of subnet masks. It's a tool that takes in an IP address and a subnet mask and in return provides you with a plethora of information. It can tell you the network address, broadcast address, the range of usable IP addresses and even the total number of usable addresses. But its utility doesn't stop there. The IP Subnet Calculator also aids in network planning and design. By providing a visual representation of the network structure, it allows for a more intuitive understanding of the network's arrangement. It helps identify potential issues such as IP address shortages or wastage and enables you to make informed decisions on how to best allocate your IP resources. The IP Subnet Calculator also promotes efficiency. With this tool, you can quickly determine the optimal subnet mask for your network without having to manually calculate and cross-check information. This not only saves time but also minimizes the possibility of errors, ensuring a smooth and efficient network configuration process. The IP Subnet Calculator, as you see, is an essential tool for anyone dealing with network configurations. Let's wrap up what we've learned about subnet masks and subnetting. We've journeyed through the intricacies of network communication, shedding light on the pivotal role of subnet masks. These masks, as we've discussed, are crucial in defining the structure of an IP address, discerning between the network and the host. They simplify network configurations and enhance clarity, ensuring that devices can interconnect efficiently within a network. We dove into the art of subnetting, a technique that allows for the creation of smaller, manageable subnetworks within larger networks. This process optimizes the use of IP addresses, facilitating efficient network communication and reducing the risk of IP address exhaustion. We also explored the role of an IP Subnet Calculator. This handy tool aids in the complex calculations involved in subnetting, saving time and reducing the potential for errors. It's a valuable ally when dealing with the binary and decimal notations of subnet masks, so let's not underestimate the power of these concepts. They form the backbone of our modern network communications, making the digital world we live in possible. Subnet masks and subnetting are more than just jargon, they're the nuts and bolts that hold our networked world together. And there you have it, a comprehensive guide to subnet masks and subnetting. Remember, effective network communication is the key to a well-functioning network.